My name is Jarek and today I'm going to present you how to perform DHCP starvation attack and the Rouge DHCP server implementation to unsecured network by using the Kali Linux. For the purpose of that presentation, I'm using a couple of Cisco 1841 routers, Cisco 2950 48 port layer 2 switch. A VM host machine is actually hosting a single virtual machine with Windows Server 2008, and this is the main DHCP server for entire cluster of that network. The attacker machine, which is Kompaku netbook with a Kali Linux fresh install that initially gets the IP address from the DHCP server. Also the victim machine. Victim machine has two Ethernet adapters, the one built into the laptop that is connected directly to the Cisco 2950, and it is configured to dynamically get the IP address from the DHCP server, as well as a USB 3.0 A6 LAN adapter that is statically configured. That setup allows me to use a remote desktop connection from my terminal machine, so I can actually show you how that PC communicates during the DHCP negotiation process. Um, I also use a terminal machine, which is a Windows 7 laptop. And on that Windows 7 laptop, I've got a PuTTY configured with X11 redirections. That X11 redirections allow me to view the graphical pop-up windows from the Kali Linux machine directly to my Windows 7 terminal machine. To be able to do that, I also run the Xming server on my terminal, a vSphere client, remote desktop connection, and Camtasia Studio. I believe it's worth to mention that the only pre-configured option on the Kali Linux machine is the SSH service enabled, so I can remote to that laptop via the SSH. So the first step will be to present the configuration of network devices that I'm using in my topology. The first one will be the access switch for the VLAN 100, which is the LAN that we will try to spoof by Rouge DHCP server. Let's do show run command. As we can see, there's no security options applied to any of the interfaces. All of them are assigned to a single VLAN 100. The port number 48 is used as a trunk to the default gateway, which is Cisco 1841. So let's telnet to that Cisco router now, 10.30.100.1. And again, we'll do the show run command. And as we can see, the sub interface fast Ethernet 0/1.1 is default gateway interface VLAN 100, and the IP helper address points to the DHCP server on the VM host here. Before I go to the DHCP server configuration, I will double check if both of my hosts are reachable through the network. So let's try to SSH to the Kali machine first. And as I mentioned before, I will use X11 redirection or forwarding to be able to view all that pop-up windows. So let's mark this, and I'm expecting to have that host on the address 10.30.100.10, and we'll use the SSH. As we can see, the Kali machine is reachable through the network. Let's try to use the remote desktop connection to get to the victim machine. IP address that I'm using to remote to that PC is actually the IP address of that A6 USB 3.0 LAN adapter that will be up and running regardless of the DHCP status. And as we can see, the Windows 7 victim machine is reachable. On every computer on that network, I have a Wireshark installed, so we can actually see communication coming in and going out from every host. On the victim machine, I'll go to command line to show ipconfig. As you can see, we've got two LAN adapters here, and This one here is the A6 USB 3.0 adapter with a static IP address, and the one in here is actually the dynamically assigned IP address from the DHCP server. Once we've got all the hosts connected to the network, we can go to the DHCP server. So let's open the console here. DHCP settings. Here is our domain, which is server1.lablan.com. And within that domain, we've got one scope configured for the victim network. The address pool is between addresses starting from 10 to address 50. And the reason for that is because I'm going to use the higher pool on the Kali DHCP server. We can also view the currently leased addresses. The one is leased for the Kali, and the second one is actually leased to the victim machine. There's no reservation for that scope, and the DNSs I'm using for that network are the DNSs from Virgin Media, who is my internet service provider. Before I start the attack, first there's a few things to be done on the Kali Linux machine. As I said before, this is actually the fresh install. So the first thing we will do will be the update of Kali source list repositories. To update the source list repository, we actually need another SSH session to be configured to the Kali Linux. And now in here we will navigate to the directory of source list file. And now we'll list the files, and in here we can see that the source list is actually here. So this is the file we are going to edit. In the second window, we will go to my home directory where I already have my files with the proper configuration for the source list and interfaces and DHCP server. So let's list files here. So as we can see, we are actually at the root directory, and now we should have home directory under here, and it's here. So cd home, and now ls, and we can see all three configuration files that I prepared before. So the next step will be to open the sources file. And in here we can see all the sources for the source list file in actually in the Kali Linux config. So let's open the source list. In here we can see that we've got only one source, so add all of these into here. This is actually the first time I'm doing this over the SSH session, so I'll try to copy that. That's it. As we can see, first two lines are exactly the same, so we'll delete one of them, and we'll save the file by pressing Ctrl and O, and now we will go out by pressing Ctrl X. Once we've got our source list updated, we can actually update and upgrade entire system. Now we can see system is updating. This process will take several minutes, so I'll pause my recording. And once the system is updated, now we can run the upgrade command. And once again, this process will take several minutes, so I will pause the video. The Kali Linux is now updated, so we will install the DHCP server on it. Let's go to the command line, and we'll use sudo apt-get space install isc DHCP server. The DHCP server installation is now complete, and the next step will be to configure the IP address of the interface, because as I mentioned at the beginning, the current IP address is actually leased from Windows 2008 DHCP server. So basically, to run a server, we need a static address on that machine. Now I'm going to navigate to interface configuration file, which is in network directory. We'll list all the files, and as we can see, the interfaces file is the one that we are going to configure. So this is the content of the interfaces file. And basically what we need to change, we need to get rid of that line in here. The allow hot plug ETH0 line for some reason doesn't work on my netbook device. What it should do, it should actually restart the interface when the kernel detects a hot plug event from the interface. However, it is not working on my in my configuration, so I will replace that in auto ETH0 command, and basically auto ETH0 command starts the interface upon start of the system. What it means basically that I have to restart the entire Kali machine. So let's change that to auto. And the remaining configuration I'll take from the file that is created. So let's list all the files again, and the name is interface config, so we'll do nano. And this is actually entire configuration for that interface. Okay, so that's the configuration copied to the interfaces file. So let's save this file now. Control O, enter, and now we can exit from here. And now, as I said just a few seconds ago, I need to reboot this machine. Basically, the Kali is up just now. So what we have to do, we actually need to use that IP address, which is the static IP address that I assigned to the port. So we'll open PATI and we'll mark the X11 forwarding option, and now we'll use 10.30.100.15. Here is information that connection was refused, and the problem is actually that I never configured the Linux host to launch the SSH service at the startup. So what I'm going to do is run manually the service SSH start command on the Kali Linux. Now the SSH service is activated, so I should be able to connect through the SSH to the Kali Linux host. At the moment, we've got our Ethernet 0 interface configured with the IP address of 15 in our network. Let's confirm that by issuing ifconfig command. And here we can see that this is our static IP address for Ethernet 0 interface on Kali Linux. So the next step will be to configure the DHCP settings. So to do that, we actually need to navigate to DHCP directory. So we issue cd/etc/DHCP, and in here we should have a DHCPD configuration file. So let's issue ls. This is the file that we are going to edit. So once again, we need another window open. I will navigate to my home directory here, and we'll open a DHCP setting. So we'll do nano DHCP underscore setting. And this is the configuration that I'm going to use within that file here. We'll open up dhcpd.conf. Here we have examples of the configuration as well as default lease time and maximum lease time already set it up. So basically we don't need these two lines here. As we go down the config, all of these hashed lines are ignored. So we need to get to the bottom of the file, and then here I'm going to paste rest of my config. So that's it. Now I'm going to save this dhcpd.conf file, and we'll exit from here. And the next step will be to test if the DHCP will start. So we'll issue cd, go to my root directory, and we'll issue /etc/init.d/isc-dhcp-server space start. So this is it. This is the DHCP up and running on the Kali Linux machine with configured options that are visible here. However, I will stop that service now because before we start to issue spoofed IP addresses, we will need to flood the existing DHCP servers so it won't be able to issue any additional IP addresses. So now I will go to my DHCP server machine. It is actually quite important to run the Wireshark just now so we can see all that DHCP discovery packets. So I will choose the interface. As we can see, not much is happening at the moment on that interface. So we will start capture the traffic. And now I will go back to my Kali Linux and will launch Yersinia in graphical mode. And this is it. That's the Yersinia window open actually through the Xping on my Windows 7 terminal machine. So in here we will launch the DHCP discovery packet attack. Right, so before I start that discovery packet attack, I will go to my scope and display statistics. So we can see that there's 41 available IP addresses in that scope at the moment. Let's go back to Yersinia. And now I'm going to issue that discovery packet attack. So press OK. Now in here we can see that the DHCP server already got over 15,000 DHCP discovery packets that are actually spoofed by Yersinia. Now we will go to our victim machine, and in here we will release the address. Actually, the address was released already. Let's see ipconfig. So there's no IP address configured for the second interface. And now we can actually start the DHCP server on our Kali Linux machine. So we'll issue etc/init.d/isc DHCP server start. This is the DHCP server started on Kali Linux. And now we will try to renew IP configuration on Windows 7 victim machine. And after a few seconds, we can see that the IP address that was assigned to that laptop is actually in the range that was configured on the Kali Linux, which is starting from 100 address. In this part of my video, I'm going to show you how to mitigate the DHCP starvation attacks and Rouge DHCP server attacks by applying port security and DHCP snooping features to the Cisco Catalyst switches. Let's start from port security features. The first line enables the port security on particular switch port. The second line specifies the number of MAC addresses that can be learned from particular switch port. The third line specifies the violation mode. In my scenario, this will be set up to restrict, and what it does, it basically tells to the switch that when the maximum number of MAC addresses is reached, it should drop every packet with unknown source MAC address until the sufficient number of MAC addresses is removed below the maximum number, and it increments security violation counter. The port security MAC address sticky command gives the switch ability to dynamically learn MAC addresses on that port and saves them to the running config. And the last two lines sets the aging time to 2 minutes of inactivity. And now I will move on to the DHCP snooping options. I have splitted them into three groups, and the first group is global configuration commands. First line enables the DHCP snooping globally on the switch. The second one does exactly the same but on particular VLAN or range of VLANs. The second two lines basically are applied to untrusted ports. First one is enabled by default. No IP DHCP snooping trust is the default option for the interface. And IP DHCP snooping limit rate 10 sets the limit rate to 10 discovery packets per second. And finally, the trusted ports and uplinks are going to be configured with IP DHCP snooping trust command. So now I'm going to apply all these settings to the access ports and to the trunk. And we'll see what happens when I try to do the same attack once again with secured network setup. I'm going to add these two lines into here. And now I'm ready to telnet to that switch, which is 10.30.100.2. I'm going to use the range command so I can apply these settings to 47 access ports. Now I'm going to copy that. I'm also going to apply the global settings for the switch, as well as IP DHCP snooping trust to the trunk port, which in my case is port number 48. Now let's confirm that all the settings were taken by the switch, so we'll exit from here and we'll do show run. As we can see, all the settings were accepted. Let's go to the trunk, and the trunk also accepted IP DHCP snooping trust command. And here are the DHCP snooping configuration for the global config. In this last part of my video, I'm going to examine the results of security settings applied to the switch by performing DHCP starvation attack and DHCP rogue server attack. So firstly, I will start Wireshark and Yersinia on my Kali machine. And now I need another window to open Wireshark. In my next step, I'm going to display port security statistics on my Cisco Catalyst switch. To do that, I will telnet to my switch. And we'll use show port security command. That command displays security settings for each interface. And as it can be seen, you can identify the maximum number of MAC addresses allowed on each port, as well as the activity on the port. So you can actually see that port number 3 and port number 5 are used at the moment, where the port number 5 is used by the attacker machine and port number 3 is used by the victim machine. So I expect to have security violation counter increased on that port straight away after I start my DHCP discovery attack. So now I will start packet sniffing on my server, victim machine, as well as on the attacker machine. So let's go to the server first. I will restart packet sniffing on the server. Now I will go to my victim machine and we'll do the same. This is the adapter that is connected directly to the Cisco 2950 switch. So I'm going to ignore the one that I'm using for my remote desktop connection. And the last one will be my Kali Linux. And now I can proceed to DHCP discover flooding. I'm going to run that for about 5 seconds. And now I'm going to examine the results of my DHCP discovery attack. So let's start from the switch by showing port security command. And on the port number 5, as I was expecting, we have 83,000 security violation events. And these are all the discover packets sent by Yersinia. And in here we can see the Wireshark that captured the traffic from the attacker machine. And we can see all these discovery packets sent to the switch. However, if we go to our server, we shouldn't see any discovery flooding captured by the Wireshark. And now I can proceed to the Rouge DHCP server implementation to my network. before I start, I need to mention that I had several issues. I couldn't get any IP address from any of the DHCP server on the network once the per VLAN snooping was applied. It took me over 4 hours to investigate the issue, and finally I find out that this was caused by the DHCP snooping information option 82, which on the Cisco switches is enabled by default. So in my scenario, I basically had to issue no IP DHCP snooping information option command that disables option 82 globally on the Cisco switch. Briefly saying, the DHCP option 82 gives the chance to assign an ID um, to any device that is going to carry the DHCP request from the client to my DHCP server. Um, and then on my server, if this option is configured, the server can decide to ignore this request or to respond to it. So now once I have everything working on my network, I will briefly go over the config of the switch once again. So as you can see, there's an IP DHCP snooping enabled on VLAN 100 and globally as well, plus that additional option that disables the snooping information option 82 on that switch. If we go farther down, we can see that here is the interface where the Rouge DHCP server is connected, and here we can see the MAC address of it. Here is interface number 3, where I have my victim machine connected. Both of them are configured with IP DHCP snooping limit rate 10. If we go further down, on the port number 48, there's a command that tells that this is the trusted port. So now I will actually start the DHCP server on my Kali Linux. So this is the DHCP server started on the Kali Linux machine. So now I have two DHCP servers running on my network. Let's confirm that by pinging them from my victim machine. We'll ping the Rouge DHCP server first. And now I'm going to ping the proper DHCP server. So the next step will be to release current IP configuration. And as we can see, there's no IP address assigned to the Ethernet adapter. And now I'm going to renew IP configuration. And the IP address that has been assigned to that interface comes from the pool that is actually running on the real DHCP server. And this can also be confirmed by refreshing the scope. And we see that this is the address leased to the victim machine. To make sure that my victim machine will not get an IP address from the Rouge DHCP server, I just deactivated the scope on my real server, and now I'm going to renew the IP configuration on my victim laptop once again. As it can be seen, there is no response from the server, even though that the DHCP on Kali Linux is pingable. I'll double check if the DHCP server is running on Kali. We'll stop the service and start it again. After a couple of minutes, there is an error message saying that the DHCP server couldn't be located. So this means that switch correctly blocks the DHCP server that is running on the Kali Linux. And this is the end of my video. I would like to say that this was a great chance for me to gain new skills in Linux, as well as in securing the layer 2 within the networks. I hope you enjoyed.